Hello, students. Got a couple questions out of section 3.4. Section B, first question was on 2C. So let's take a look at 2C. So here's 2, and I'll zoom in just a little bit more here. Okay, so 2 says if A equals this, B equals this, find the following. Find A cross B. Okay, so that's all the ordered pair matches up. So A goes with X, A goes with Y, A goes with Z. So you're finding all these ordered pairs. Part B says find the number in A cross B. So the number in A cross B is going to equal how many of those ordered pairs did you make? And so there's 4 in the first set, there's 3 in the second set. So you should have 12 ordered pairs, what you should have, because each one in the first set pairs with everyone in the second set, right? So yeah, so B is like, it's going to equal 12. So I guess the question is, what do I do? So B is 12. Write the multiplication equation. Oh, okay. So it's asking you to write the equation that comes. Let's take a look here. Make a little white space going here. Okay, there we go. So I think there was a similar one in part A. So we'll do a slightly different one. Just so we tie everything together. All right, so here we go. So let's just say that in my example, I'll do an example here. A is equal to AB, and B is equal to, I'll just do X, Y, Z again. Okay, so if you are doing A cross B, you are creating a new set, and it's a set of ordered pairs. So my ordered pairs would be A goes with X, then A goes with Y, then A goes with Z, then B goes with X, then B goes with Y, then B goes with Z. And so that's all that I have in this, what's known as the Cartesian product, or sometimes called A cross B. Okay, it's not multiplication because sets are not numbers. It would be multiplication if it was between two numbers. Okay, so now, so this would be like part A. Part B says, tell me how many are in there. Well, how many are in A cross B? And that you could just count them up if you need to. 1, 2, 3, 4, 5, 6. There's 6 ordered pairs. So I'd write 6 down. And then part C says, now write a multiplication equation. Okay, using numerals. So the numerals are how we write numbers. Numbers, the idea, numerals, how we write it. So what numerals did I multiply and what equation can I make? So I need to write an equation. And if you look at the first two parts, I have a list of all the options here. So A cross B, A has 2 in it, B has 3 in it. So what I really can see here is that I need to use numerals. So I would be writing the equation of A has 2, B has 3, and my end result would be 6. That would be using the numerals. Okay, and notice that does tie back in. It's the number in A times the number in B, and that's equal to the number in A cross B. So this is like the general, and all we're doing is using numerals to represent our specific example. Okay. All right, let's see here. Let's clear all the drawings. And what comes next? Next is for question 24. Okay. So I got to jump to the next page. Here we go. Question 24. Which one is that? Oh, here we go. So I think I did one of these in the part A. So I would most likely I would rewrite this. But let's jump a little white space in so we can make sure we're on the right track. All right. You know what? Maybe a little bit more. Let's bring some over here too. Okay, now we got plenty of room to work. And now, okay. So I think the first thing, just make sure, I mean, you're using bases, right? So I have base A and base B. So I have 4, 1 base A is equal to 1, 4 base B. All right. So I would write this out, in place value notation. So kind of an expanded notation. This would be 4 groups of A, whatever A is, plus 1 group of 1 has to equal 1 group of B plus 4 ones. So now I've got the connection there. Maybe I'd even subtract 1 from both sides. So I have 4A is equal to B. What do I want to put in here? B plus 3. And then maybe I'll even, I don't know. I guess I could have brought the 4 over to the other side. I'm trying to see which one looks a little bit easier to do. It almost looks to me like because B is already kind of by itself and isolated, maybe I should bring everything to the left-hand side. So then I'd have 4A minus 3 is equal to just B. And the reason why I like this one better than what I had up here is in the one up here, if I do plug a number in for A, then I have to do a little bit of work to solve for B. And if I plug the number in for B, I'd add 3, but I'd still have to do a little work to get A by itself. If I rewrite it like the one down here, I can just pick a number for A, like any number for A. So now notice, take a look at A. This is the base. So taking a look here, I noticed that I go up to the digit 4. So could A be 4? Well, remember, base 4 would include a 0, a 1, a 2, and a 3. It has 4 digits, so it could not be 4 because there's a digit marked as an actual 4. So I don't have that. So what I need to do is rethink. So I guess the lowest it could be is 5 for A. Yeah, I think that's the lowest. Okay, so now plug A in for 5. So I have 4 times 5 minus 3 is equal to base B. 4 times 5 is 20. So 20 minus 3 is equal to B. So B is 17. So now I know B is base 17. And if A is 5, if A is base 5. And now you can kind of check this on your own, right? If this was 4, 1 base 5, then it'd be 4 groups of 5 plus 1 if I was turning this back into base 10, which is 21. And if I came over here and I did 1, 4 base 17, pretty weird, then this would be 1 group of 17 plus 4. And 1 group of 17 is 17 plus 4 is 21. So they come up with exactly the same value in base 10. So that tells you there they go. And I could not choose a smaller value of A. I couldn't choose a 4 because there's already a digit 4 in here. So it would not be an appropriate way to write the answer to that. That's probably what I would do. Do a little bit of algebra and then plug in some numbers. Use a little thinking from what we do with all these components. All right, let's see here. So, oh, and by the way, there's a ton of other answers, right? I chose base 5 as my starting place, but I could have chosen base 6, could have chosen base 7. The reason I kind of went was it says choose the least values. If it just said find values, yeah, go ahead and plug in whatever you want. Plug in A equals 6, plug in A equals 7. And again, plug that in and you can figure out what base B is. Let's see here, what's next? Number 27. Okay, so number 27 is here. Give reasons for each of the steps. All right, if you say so. Okay, so remember the first step goes from the left to the right. So someone has rewritten this in expanded form. So this is expanded form. And all they did here is rewrite it. So in a sense, factored it, because 10 squared is rewritten as 10 times 10. You could also say rewritten in exponential form. I would take either one of those. Okay, then next step going down is distributive. Distributive property of multiplication over addition. And then now the parentheses are regrouped. So that's associative of multiplication. Next up, yep. 10 to the first times 10 squared. We have the same bases. We add the exponents. So this, I would say, is the law of exponents. But I believe this book has like a theorem number for that. So if you went back and found the theorem number, that would also be just fine. And then what do I have here? This is just that multiplicative value of 0. You have basically nothing over here. So you can call it 0 as a numeric representation of that. So 0 product property, right? So if I multiply anything by 0, I get 0. And then coming all the way down to the very bottom, the last thing we would do is the standard form. I'd also take place value form, I think, because you're just kind of rewriting the place values in standard place value format. All right, let's see here. This question was 35. Let me turn the page. 35. Use your calculator to multiply several two-digit numbers by 99. See if you can find a pattern that lets you find the product of any two-digit number and 99 mentally. All right. I better try something with Desmos then. So it says pick a two-digit number multiplied by 99. Okay, Desmos. Let's jump in here. You could use another calculator if you wanted to. Let's see. $20 times 99. 21 times 99. 40. Oops. 43 times 99. Okay. So I think as I was looking at this, instead of trying to think of how did I get the multiplication over there, I want to try to look for some patterns. 99 is very close to 100. So if I did 43 times 100, that would be 4,300. We saw that in class, moving the place values. So 4,300 is 100 of these. 4,257 is 99 of these. The only thing that's different is I've taken away one group of 43. So it's like 43 times 100, but then I'm taking away one group of 43. So that'd be 4,257. Now you can use the techniques we did in class. That was weird. Hopefully it is still recording. I guess we'll find out. Let's see here. So for I have no idea what happened there. All of a sudden it said reconnecting. So let's see here. Where were we? 4,300 minus 43. So think of it, 4,000 minus nothing is just 4,300. Then I take away 40, I take away 3. So this becomes 4,260, and then you drop 3, and you get 4,257. Okay, and that matches over here. So basically, if you're doing this, take 100 of what you have and take away 43. Okay. So that's the idea. And that works for all of them, right? 21 times 99 would be 21 times 100. Well, 21 times 100 would be 2,100. And then you just drop 21. So 2,100 drop the 20 would be 2080, and then drop the 1, 2079. And you can get there without having to do the multiplications. And hopefully that makes sense. I mean, you're multiplying by 99. So you just think to yourself, 99 is equal to 100 minus 1. So whatever number you're multiplying by 99, you could multiply that same number by 100 and then subtract that number. That's 100 minus 1. And you get exactly the same place. And to be honest, probably easier than long multiplication of 99 times some number, because multiplying by 9 tend to gives you a lot of regroupings. So it just ends up being a little bit more complicated. All right, I think that about wraps it up for this one based on the questions I received. Hopefully it works for you. All right, have a good night. Off you go.